Is 3D printing the future of construction? Join us as we discuss this and more on 3D Print the Future with your host, Frank Awesome.
Hello and welcome to the show. If you're new to the channel here on 3D Print the Future, we give our listeners first-hand experiences shared by business owners, industry experts, and passionate leaders. We'll discuss how we got here, the incredible things that are being done now, and of course, where this technology could possibly take us in the future. Graduating from SAIT in 2005 with an electrical engineering tech certification, my guest today brings over 14 years as an electronics technician to the table. His experience in the industry has ranged from basic repair and maintenance to research and design. This includes installing and testing new equipment, service and maintenance on existing equipment, both on land-based locations and offshore installations. During this time, he was able to work in North America and abroad, and was constantly invigorated by the new challenges he was able to experience and overcome. Please welcome the Director of Systems and Controls for 3D Printed Homes Corporations, Gary Tarasoff. How you doing, Gary?
Hey, not bad. And you, Frank?
I'm doing good, man.
Sure.
This podcasting is really getting off the ground, so I'm pretty excited to talk to you today. You're the last of the directors to be put under the knife.
Right on.
So we're going to get to it here, and I just want to know the same thing I kind of asked the other directors is, you know, firstly, what sort of made you choose a career in electronics? You know, what kind of got you to that point? And then I'm going to ask you about how you got from there to suddenly being involved in 3D printing construction. But first, I want to start with a bit of your history. How did you get involved in electronics and that sort of thing?
Yeah, I've always been a little bit of a geek in the electronics and computer side. So decided to try that out at SAIT, and yeah, long story short, I guess, ended up here. But you know, I've always kind of had an interest in it and love the science side and the technology side and anything that's kind of new and innovative and sort of on the Star Trek cutting edge. So it was a logical path to take, I guess, in post-secondary school to try and figure out how it all worked.
Oh, that's cool. Did you do a lot of tinkering as a kid? I mean, did you have, you know, electronics kits, or did you, you know, did your parents let you? I know my toys involved pulling things apart.
Oh yeah, for sure. Yeah, everything came apart. It didn't always go back together, but
No, it didn't.
the standard kind of electronic kits, and playing around online and seeing what else you can learn. You know, going out to different groups and events when they had them on, and you know, many robotics things or electronics things or you know, amateur radio events and everything. Just trying to learn as much as I could and fill my mind with whatever new interesting geeky things I could.
What kind of programs did they have in school when you were going to school? So it'd probably be more like, you know, high schoolish stuff, you know, industrial arts and things like that.
Yeah,
did they have contests and, you know, or any kind of, you know, places where you could sort of showcase your work, like even a science festival or?
No, not my neck of the woods. And back then in Calgary, there wasn't, I don't think, quite as many small kind of hobby groups. But yeah, we had you know, the standard computer lab in school and a little bit of a networking lab in school. And then, you know, other than that, most of it was just done on personal time. And
Right.
Yeah, there was some of the basic kind of electronic auxiliary courses you could take in high school, but they were relatively limited at the time.
Yeah, we were in school a little bit too early. You know, nowadays we have, you know, since 95 when, you know, social media sort of started taking off, and then you get into, you know, the 2000s, 2005, and now there's, you know, social groups online that you can connect with and then go and, you know, go visit them in real life and have meetings and stuff like that. We didn't have that when we were in high school. We had whatever programs they offered, and that was pretty much it, didn't we?
Yeah. You were kind of stuck with it unless you were in a, you know, high school that was, you know, designed more so for the technical kind of trades. And then, yeah, our high school was in a bit of a smaller town, so you were kind of limited as well. But yeah, we also, you know, we did have the access to the internet and everything at the time, so you know, you could still. It was right on the sort of the start where you could start learning a lot more online and learning, sort of learning for free, more or less.
Well, you're lucky. I'm a little older than you guys. We didn't have internet. I mean, we did, but it wasn't called the internet when I was in high school. It was just starting. Coding was just all about coding in DOS. If that's even a term that's used anywhere anymore, I don't know. But yeah, so yeah, I guess you were lucky in a way. You did get to experience a bit of the internet and getting into groups and whatnot in the school. So what did you do like right after school? Did you end up going to college, or did you just move
Yeah,
around for a
right
bit?
out of high school. Yeah, I went to SAIT to take their electronics course they had there, and then basically right after that got into oil and gas industry and mostly repair of gas detection systems and well site data acquisition systems, and just kind of worked up from there from a relatively mom and pop company up to slightly larger, more professional style organizations, and but yeah, just brought me to where I am, I suppose, today.
So this company that you're working for now, I forgot to write down. What are they called? What's the name?
Currently, I'm working for Turkana. We do some a little bit of R&D work
Turkana, that's right.
and
Yeah.
some imaging and things like that. So it was kind of a transition or a seamless transition from my last job. Working at Weatherford in oil and gas. It was some similar sort of things. You're always trying to innovate and do a little bit of research and design work and figure out how to make the equipment last longer and try to figure out how to make it for cheaper and try to get it out on more jobs.
That's kind of the way to go. So what kind of jobs are you doing? You were doing basically radar style testing for downhole, things like that.
No, well, Weatherford, it was mostly gas detection and drilling parameter monitoring pressures and temperatures and drilling speeds. And then the data acquisition system would collect all that and apply calibrated values where it had to, and then store it in the database. And then from there we could generate out some logs and give it to the client as sort of a final thing.
You do a lot of just strict data collection.
That was mostly what it was. From my perspective, or my side of the operation was more the actual hardware and just getting the stuff into the computer, right. And then there'd be actual more geology professionals that would interpret the data and generate out some of the final logs and things.
So then, when you were in high school and you were all interested in this, electronics, it was obviously something that your brain was onto you because you followed this path all the way through. You didn't even take a break between high school and college. So, and now suddenly you find yourself thinking about getting into construction, and not just construction, but 3D printing construction. How does that come about? How does that transition happen?
It was mostly more of a transition from just a hobby to to something else. I think when you originally had mentioned that there was some interest in 3D printed homes and things, and I enjoyed some 3D printing and additive material or additive manufacturing. That it was just something else, again, kind of Star Trekky, that was interesting and potentially on the future cutting edge. So sure. something kind of new to bite your teeth into, and I never really had any of the experience in the construction side, so it's always nice to see another industry and see where you can apply your technical skill set to something different. Keeps it fresh, keeps it interesting.
So how do you plan to do that? What are you doing? Tell us what you're doing I'd love to sell you. I'd love to stand there and tell everybody all about you. But what do you do for 3D PHC? What's your specialty, or what's your
so for the most part, it'll be just a matter of everything from sourcing machines, working with David to make sure that whatever technology is available, that we can utilize it and bring it into Canada. Right to some of the systems and software integration between modeling software to final printing software, and even working with some of the business side and figuring out what's required for standards and regulations, because that all kind of trickles down to kind of what your machine needs to do and what your electronic systems need to accomplish to sort of maintain those standards and to keep repeatability up.
That's the hugest hurdle, isn't it? Trying to get past regulations and even just, the government trying to get past all those people.
Yeah, for sure. Yeah, not even just trying to get past, but just trying to understand a totally different industry that's a big rabbit hole of regulations and, multiple regulations and conflicting regulations, and trying to see how you fit a new technology into the existing specifications for how to build structures.
I've always felt you kind of got to fit the regulations in first before you can go do any big jobs.
Oh yeah,
because
yeah.
they don't care what you can do if they don't think that they're going to let you do it.
Yeah, exactly. It's always a bit of a balance trying to change the world while trying to maintain within its existing guidelines.
Isn't that the truth? So in your opinion, I want to kind of get into some more fun stuff now. There's a few companies that are really starting to kind of make waves even around people that haven't quite been exposed to 3D printed construction. And these companies are Cybe Construction. Some people pronounce it Cybe, but we always pronounce it Cybe. Apiscore, again, we tend to pronounce it Apicore. So Apiscore, Apicore. SQ4D is making waves, but not in the same way, not in the housing scene, but in the design challenge scene. And then of course there's Cobod, who's making huge waves right now, and Icon, who is kind of went a little bit plateaued lately. So there's 35 or so companies around the world that we know that are actually doing something. But of those companies that we mentioned, the ones that we know the most of, which ones do you think have the most, the most ability or have the best product available right now?
I mean, for the most part, it's activity-wise, Apicore and Cybe and the Cobb ones are, they have the most recent marketing material, the most recent tangible evidence that they can actually build something and build it rapidly and kind of do what they say. So, it's good to see that they're sort of keep starting to continuing to innovate and actually having some final products to show now. It's kind of nice to have multiple companies looking at different electromechanical systems, different designs of the actual machines. Some are articulated arms, robotic style machines. Some are gantry style machines. So I do like the selection. Now between them though, it'll be kind of one of those Betamax VHS things. I guess we'll just have to see which one pans out and which one either has a better marketing or which one in the end of the day has the better machine for the structure you want to build, whether it's a house or a apartment building or a shack in your backyard.
That was a really good analogy to the Beta and VHS, because the people that were bringing out Beta thought it was really going to be a thing. They really they were going to take the world by storm. And at the time, it seemed like a good idea, but it was so little, so late that it never really turned out. I hesitate to think that that's going to happen with this particular industry. I think we're just enough at exactly the right time. But I mean,
and it's you're not two gigantic technologies competing. It's kind of I think each company is going to sort of eke out their own portion of the industry. Depending on location and design,
and ability. Some people will do a lot more added value stuff.
Oh yeah.
Other people will do a lot more housing stuff. And then I was speaking with a couple of other guests, and there have been things brought up like we've thought about disaster relief a lot, but we don't really think about things like bridge building or landscaping.
Yeah.
What do you think about that?
Oh yeah. I mean, it's I use structure as more of a generic term, but
fair enough.
Pretty much any kind of thing, I guess, that you want, theoretically can be produced in a sort of additive manufacturing style way. Yeah, whether it's landscaping or artistic or retaining walls that don't require a large number of pre-manufactured forms and a lot of time to construct the forms and tear them down. Right to printing, permanent flower boxes that sit on your property and on your corners. So it's it's pretty much if you have a thing that you want to be made out of an extruded material that lasts a long time and that can be reduced in shapes quickly and more efficiently and in most cases a lower cost. This is the technology that'll be able to do it. And do it repeatably.
Some of the smaller companies that are doing it, the smaller companies that they're not trying to be, huge companies. They're just kind of doing it for fun in some ways or research. And they're printing things like steps to go up hills You know, they just print everything on their side. They're printing benches and chairs. They just print them on their side and then tip them over, and suddenly it's a chair that's 3D printed out of concrete. I really like that stuff as value added stuff. So getting back to your sort of technical expertise, because I find that phenomenally more interesting. If you were then, I'm going to give you a hypothetical here. If you were to be in charge 100%, had all the money that you needed, not an issue, all the resources you needed, not an issue, build your own sort of machine, and taking from what we know maybe of other machines that have done one job really well, but maybe another job not so great. What kind of machine would you build? And is that something you could even describe?
Ooh, if money was no option, I mean, it would be, yeah, for sure, just some kind of a track mounted system that you put up a couple of electronic data points in the surrounding environment, and then the system would know exactly where it is at all times, and you hit go and it unfolds, and you plug a material supply hose into it, and it does its thing for the next couple of days, and then calls you when it's done, and packs itself back up, and you go on to the next job, assuming money and resources were no constraint.
Easy peasy, right? It just shows us what the real challenges are. Bringing in a new industry, and the challenges aren't necessarily making it work. It's getting it working.
Oh yeah, for sure. And yeah, trying to scale up existing 3D printer style technology to something that can go 2 or 3 stories high, and work within the constraints of the environment that it has to work in.
No, that's a really good point, actually, because we plan to do things. We really want to go up and print on the tundra in the Northwest Territories. We've been talking about printing pads in place so that you can do that. Now, to do that, I would imagine that we would need to have some sort of self-level ability. In your mind, how would that work? Is that something you would use scanners for, radar? What sort of things would you use to auto level on the ground?
Yeah, just for auto level, sets of laser type systems, and combined with accelerometers and things will tell you exactly is your extrusion system running straight, and is it running in the right direction based on where you've told it sort of your zero position is in it. So yeah, I mean, you can do everything from with that technology, you'll be able to keep a nice straight platform on a rough terrain, whether it's a hilly area or a rocky area. You wouldn't have to smooth it out first. The system could just 3D scan it, either with a visual 3D scanner or laser scanner, and it would know the dimensions on what it has to print on or build on, and then it would know where it's at, and could follow that contour. So if you wanted it straight, it would print straight, and if you wanted it to follow the contour and maintain a certain distance above the contour, it could happily do that all day long, and repeatedly do it all day long.
That's a beautiful thought, and it kind of really goes along with that. Having everything in one vehicle on one truck with a bed that can be lifted on or off. All of your elements are there. It's a one truck, 2 guys operation. Get to the site, get everything out. The construction workers are basic maintenance and supervision. That's all they really do. And you can, I mean, I like the idea of being able to scan the ground and then feed that to your computer. Like, you've already have the building design sliced and ready to go, but it's sliced for flat ground. So you'd have to be able to have the algorithms that say, okay, well, here's your flat underneath. This is what the ground looks like. So now I have to extrapolate and fill that space with more layers to fit on the ground. Or do you think it would be easier to just print a slab on the ground, and then again, you're printing on you make your grade flat that way? Because if you're printing a slab, it doesn't really matter how wonky it is right at the beginning, because you're probably going to put piles in anyways, or do something to anchor it.
Oh yeah, for sure. You have to put some footings or something down to the frost levels, and those sort of elements of traditional design would still have to be maintained and implemented into it. But the sort of 3-dimensional printing technology will give you considerable more flexibility without having to maybe plan everything ahead, and having to have, again, custom forms made. So if you want to follow a certain slope, you don't have to bring in a bunch of lumber and cut it to shape to hold the material in while it's curing. You can theoretically just extrude it out and sort of print it and follow the overall shape of the ground. With that, then you have less waste and less chance of error. So you're not going to have to throw it away a bunch of custom forms afterwards, and and a bunch of custom material. And in some cases, it can make it safer, because you're not having to have a bunch of people in a rough area and things like that. You just tell the printer to do its thing, and kind of walk away, keep feeding it, and it's happy to go.
It sounds so simple. I could almost end the whole thing right here.
Yeah, that's it.
what piqued your interest? Like, sort of what was the first time you saw 3D print construction, or what was it that it couldn't have been me calling out for people? What was it that piqued your interest in 3D? I guess maybe it was. I couldn't imagine it would be.
No, that was kind of the first time I heard about it in sort of our neck of the woods.
Really?
But I mean, yeah, you've always seen it in science fiction movies, and even popular mechanics from like the 50s and stuff, talking about building structures on other parts of the world or on other planets and things. And it's just only in the last 10 or 15 years where the technology's evolved to the point where regular individuals can have access to that technology. You don't have to have a $100 million development budget to try and do it. A lot of the technology exists, and a lot of the understandings of kinematics and controls for those kind of systems already exist. So it's more of a plug and play of existing technologies into 3D printing different structures instead. I'm not to say to be easy. It's certainly a lot of technical challenges and scaling up existing technology to be able to do it. And let alone trying to figure out how to print at the same time as maintaining space for electrical and plumbing and things. So there's a lot of interesting technical challenges that still need to be tackled. But at very least, a lot of the electronic and software side is relatively available at a relatively low cost.
That's true. We got a lot of work to do before we even make this, to us, it feels mainstream, but when you kind of ask around to the layman, it's not at all mainstream.
Yeah, well, there's only a few proof of concepts around the world, and a few one-offs that people have done, and a few things in the Middle East that have been built. But yeah, it's it hasn't been seen everywhere. It's a long ways from being from mainstream. But at least there's a huge amount of interest in it, and there's a lot of problems that can be solved with it. Both everything from financial reasons that it's too expensive to produce some existing structures to the ability to freely build much more complex architectural shapes without having to have a huge number of people trying to build it. Where you can do a 3D structure relatively simple.
So you touched on some of the buildings that other people have done around the world. There's been more than a few. Which one sort of struck you as the most impressive? And then tell me why.
I don't know if any one in particular is impressive. I mean,
I could
a couple of the ones in the Middle East are multi-stories and things. That's pushing kind of the technology to the next limit. But even the one level sort of couple 100 square foot round shack is still I still find impressive that
the little yellow Apicore one.
Yeah.
Okay. Yeah.
Even a couple on your screen behind you. If it's a small little garage, is still pretty interesting. That theoretically one or two dudes could go out with a machine and print it off and have it done, safely and have it done, repeatedly every time. It's all pretty impressive. I can't think of any project that is extraordinary, because at this point in the industry, it's all kind of extraordinary that it can be done.
Isn't that the truth? But I think that you're mentioning that Apicore, the little yellow round Apicore house, was was, I think, especially extraordinary in a way because it was printed in Russia on frozen ground
Hmm.
in a tent,
Yeah.
and then they painted the walls and they put all this stuff in there. I think it was so impressive because it really was printed and finished in the time frame that they said it was,
Hmm.
including bringing all the stuff to the site and taking it all off again.
Yeah.
So we talk about printing houses in so much time, but just like going to the airport, you don't say it takes me 5 hours to fly to Toronto if the airplane ride only takes 3.
Hmm.
It took me an hour to get to the airport and it takes me an hour to get out of the airport, but we don't add that time. So when we
Oh, yeah.
talk about printing buildings, we don't really add the time that would take to prepare the land and all this stuff, but
Hmm.
they really did it in 2 days.
Hmm.
I think that's what really was the most impressive thing about that building for me, and was my proof of concept was, yes, they added a few remainders, but it was really was done in 48 hours. It really could be lived in. They had power,
Hmm.
plumbing, just extraordinary. So
Oh, yeah.
yeah.
Which is really the end goal of yeah, a lot of it in the disaster relief and some of the the housing in areas where you want something that can be put up quickly and that can withstand the elements, and that can be done with relatively few people involved and relatively few materials. If everything can come out in 1 or 2 truckloads and do a whole street of houses in a week, that's kind of the an optimal use case of the technology.
I agree. A fellow from Australia told me that it took them over a month to evacuate when they were having all the floods and the fires.
Mhm.
There was one spot over there where there were people trapped because the bridge got washed out,
Yeah.
and they were all trapped, and they had to boat them around the coast to get them evacuated. And once they had them evacuated, they really didn't have very many places to evacuate them to.
Hmm.
And we were imagining that you could have a couple of 3D printers on the ground in a space set aside, so that as these refugees were boated around and taken on back onto land, they had somewhere to go. And because it took them so long to kind of evacuate them all, you have time to do that. You wouldn't have time to build any kind of shacks even with wooden nails, but to
Hmm.
3D print something like that would be lickety split.
Hmm.
And we were realizing that, yeah, it's just because of the speed, because of the low waste of materials, you could do so much more with that. No doubt about it. So that kind of brings me to where you might see this industry way in the future. This is my favorite part because we get to wax philosophical. What you say doesn't have to be right or even come to pass, but where would you either like to see it, or where do you see this technology being? And you can answer any number of ways in 100 years, 500, even 1,000 or more years. Way in the future.
Oh, yeah. Yeah. I mean, um, I don't even think it's an ideal thing. I think in even a relatively short amount of time, yeah, you'll see it being used everywhere from on every street, and large buildings to skyscrapers, to outdoor shacks, to colonies on the moon and Mars, and kind of wherever you need a thing built that maybe you can't get people there, or it's harsh environment. If you can build research stations in the
Oh, that's a
Arctic
good
and
idea.
in
Yeah, I like
crappy
that.
weather,
Oh,
and
that's a
just
good idea.
to produce houses that yeah, maybe withstand fire better, and withstand flooding and water damage better, and tornadoes better,
Well, do you
and that
think
kind of
that
stuff.
it'll take over the brick and mortar industry, or do you think they'll find a way to coexist,
I think for
or some
for
combination
a
of
long
that?
time there'll be an element of coexisting for sure. I mean,
Yeah.
there's a lot of finite elements that you know computer or controlled systems can't do. They can't do fine details in houses and trim pieces, and they can't
Yet.
paint always intricate things. But
But they
so yeah,
can.
for a long time, it's not like it's going to overturn the industry right away, and it's not like a bunch of automobiles came in and phased out all the horse-drawn carriages kind of right away. It'll be a bit of both, and then both systems sides will evolve, and the system, automatic sort of 3D printing systems will be better at some things, and then you'll still have to have human hands to take care of other elements. But yeah, definitely, 1,000 years down the road, who knows? Maybe you just have a good dream at night about a house, and the system picks it up. Next day, you got it built in your backyard.
Oh my gosh, and we're almost there already. Really, we just got to get past everything. And your analogy about the horse-drawn carriages is a really good one, especially considering we still have running horse-drawn carriages, but they're used for entertainment now, and they're maybe on some of the older farms, but they're still in use.
Oh yeah.
And that's kind of what I think that the brick and mortar industry is going to end up being. It'll end up turning into 1,000, maybe 2,000 years down the road. I think you'll still see it, but it'll be a novelty rather than the wave.
Yeah, definitely a possibility. And the entire industry will just evolve to which system or what process works the best under conditions. You may still want a hand carved table in your house, so yeah, you get the people that can do that. And then if you want 3D printed curved organic shaped walls, then you use the technology that's best suited for that.
No, exactly. Just use it for what it's great for. So I think on that note, we're gonna end it for the day.
Yeah.
Unless you had something that you wanted to add, anything you wanted to promote or talk about.
No, that's pretty much it. It'll be an interesting trek to try and get it on every street corner, and try to get it to the point where it can be built anywhere, whether it's the Sahara Desert or the northern Canadian Arctic.
No doubt. Yeah.
Interesting technical challenges, and look forward to solving them.
Right on. Well, thanks for being on the show today, Gary. I really appreciate the support of my fellow directors. It's pretty awesome. I want to thank everybody else who stopped by and either watched or listened to the podcast. I hope you found it really interesting. If you like that and want some more information on 3D printed construction or where 3D printing will get us in the future, go check out some of my other podcasts and videos. I'm sure you'll find one or more of them really interesting. Of course, don't forget to subscribe and hit that bell to make sure you get notified when the next episodes go up. Once again, thanks everybody for coming around, and we will talk to you guys next time.
3D Print the Future is sponsored by 3D PHC. Find them on the web at www.3dprintedhomescorporation.com.